We're going to show you how to graph the sine, the cosine, the tangent, the secant, the cosecant, the cotangent. It's designed to be a complete guide, so let's start at the beginning. It will start with simple and we'll get a little bit more challenges to go through this video. We also have timestamps in the description below if you want to jump to a particular section of this video. So the first thing we need to talk about are the graph, the basic sine graph, and the cosine graph. And then we're going to get into the transformation, shifting, stretching, compressing, etc. We're also going to reference the unit circle and we're going to show you where these graphs come from, starting with the sine graph, where graph y equals sine of x, and if we go to a unit circle, remember when you want to find the sine value, look at the y coordinate of the point and on that unit circle. So when we think about sine, we say, okay, the sine of 0 degree, or in the 0 radians, either of 1, you can see the sine value is 1, you're going to be 0. So going to put a point right there at 0. Now at 45 degrees, okay, it's root 2 over 2, and 90 degrees it's 0 comma 1. So at 90 degrees you can see the sine value is going to be 1. So just gonna write pi over 2, or 90 degrees the y value, the output. This is going to be 1 at 180 degrees, or pi, the y value is 0. So we're going to put a point here at 0 at 3 pi over 2. Okay, our 270, the y value is -1, so we put a point down here at -1, and then at 2 pi, we're back where we started, which the y value is 0. So this is your basic sine graph, and you want to memorize this basic shape. It's going to help you as you go on to do more challenging problems. So it's, I think of this is starting at this midline, it goes up to the maximum, back to the midline, down to the maximum, and then back to the midline, and then it starts over and over, and it keeps repeating like that. You've got a maxima at the 1, minimum -1. Now what happens is, if you wanted to graph y equals 2 times sine of x, well, this number that comes in front of this is what we call our amplitude A, and what's that's going to be a vertical stretch of 2. So what happens is, instead of going up to 1, now you're gonna go up to 2. Instead of going down to -1, you're going to go down negative. And so again, that's just a vertical stretch, but still going to cross the x-axis at those some points. So now see if we want to go a slightly more challenging problem. Sailing number 3 way, y equals sine of 2x. This number here, okay, this is b value, the letter that comes, or the variable, or the constant, I should say, that comes before the variable a of x. That b value affects the period, and we can use this formula: period equals to pi over b to find out whatever the new period is. So in this case, the b value is 2. If we take 2 pi divided by 2, that's just going to be pi. So our period is going to be pi. What I like to do is kind of like mark the x-axis, the scale first. If the period is pi, we're going to divide it up into 4 pieces, just so we did here: 1, 2, 3, 4. So pi divided by 4 gives us on our scale, that's gonna be pi over 4 to pi over 4, 3 pi over 4, and 4 pi over 4. Okay, so 2 pi over 4, and 3 pi over 4, and 4 pi over 4 is pi. We can see that the amplitude is 1 because that 1 time anything itself, so it hasn't been stretched vertically at all. And we haven't talked about the shifts yet. That's the H and K. It's gonna pick up the graph movement left to right and up down. So here we can see that the graph is just gonna have this basic shape. Again, it starts at the midline, it goes up to the maximum, which is back at the midline, back to down to the minimum, which is -1, back to the midline. The only thing that was different here is that the period change. It was 2 pi divided by 2, which pi is not true that this number here has the opposite effect on the graph. Instead of multiplying x by 2, we actually divide the x by 2. Normally, the period for sine and cosine of 2 pi here, it would be divided by x by 2. New period but just 1. So let's keep going. Let's go to number 4 here. Now we're getting into y equals sine of x plus pi minus 2. So here you can see that the b value is 1, so which means that our period is 2 pi divided by 1, which is just 2 pi. So let's go ahead and mark our scale here at 2 pi divided by up to into 4 pieces: 1, 2, 3, 4. If you take 2 pi divided by 4, that comes out to 2 pi over 4, which is just 2 pi over 2 to pi over 2, which is pi 3 pi over 2, 4 pi over 2. So we're just taking this pi over 2 by 2, or by 3, or by 4, and that's how I'm getting the scale on the x-axis. The amplitude is 1, so that's being stretched vertically at all. So that means it's going to go up to a maximum of 1 and down to a minimum of -1. But the number of this group with the x that's going to shift the graph in the x direction, it has to be the opposite effect. So plus pi is actually in the shift the graph. So left pi, okay. negative pi, and then the minus 2 has the same effect. That's gonna be a vertical shift. The minus 2 is actually gonna shift it the same down to, okay, is the sign. So what's gonna happen here is we can think of this graph is shifting left pi. Now notice how our scale is pi over 2. So it's a shift left pi. That's actually like shifting left 2 steps 1, 2. So here over here at negative pi, and we're shifting down 2. So that's gonna be 1/2. So that we can think of this point right here is like our new origin, like our new starting point. Okay, so I kind of drew like a new axis and a new axis, and so what I'm going to do is we're just gonna graph here. So we're starting at the midline, we go up to the maximum, and she said it's gonna be, 1. Okay, because it's not being stretched at all, back to the midline, back to the minimum, and then back to the midline. So that's our basic graph. The only thing we did is we shifted everything left 2 and down 2, and thought of this as our new starting point. Okay, let's talk about cosine. We're gonna get into some more challenging examples involving the amplitude, changing the period, changing as well as the phase shift left and right, and a vertical shape up and down. But let's talk about bit about cosine first. So when we talk about cosine, we go to our unit circle. The cosine, we're talking about the x coordinates when we find that cosine value. So cosine of 0 degrees or 0 radians is going to be 1. So with cosine at 0, we start the 1 at the pi over 2 or 90 degrees. The x coordinate is 0, so we go back down to 0 at the pi, which is here at 180 degrees. The cosine is x coordinate negative 1, and then at 3 pi over 2, the x coordinate is 0, and then at 2 pi, you're back to where you started. The cosine is x coordinate, you're back to 1. So you can see our basic cosine graph has that basic shape like that. It starts at the maximum, it goes to the midline, down to the minimum, back to the midline, and then back up to the maximum, and it repeats. Okay, so these are called sinusoidal graphs. They have like the S shape. So now what would the graph look like if you had y negative? Cosine of x will be negative. What it does, it reflects the graph over the x-axis. So all the x values are going to be, oh sorry, the y values of the opposite exponent are going to be the same. So instead of being at 1, they're going to be at negative 1. 0 times negative 1 is still 0. Negative 1 times negative 1 is positive 1. 0 times negative 1 is 0. And 1 times negative 1 is negative 1. Again, we're just going to reflecting it. So this graph is going to look something. This dotted line here is just going to be flip again. You want to memorize the basic shape. So cosine is that basic shape. Sine is this basic shape. And let's go number 7. Now y equals cosine of 1/2 x. So just like sine, we look at the b value, that number that just comes in front of her to the left, and the variable of x, and we can see that the value is 1/2. If we want to find the period, we just say qb divided by b, which is 1/2. When you divide by a fraction, it's really like multiplying by the reciprocal. So instead of dividing by 1/2, we're going to multiply 2 over 1, just give us a period of 4 pi. So what we like to do is we like to mark our x-axis with the period 4 pi, and we divide it into 4 pieces, just like the 4 quadrants, 1, 2, 3, 4. So our scale is going to be pi, then times 2 is 2 pi, and then 3 pi is 3 pi, 4 pi is, so just 2, 4 pi divided by 4, and that's what I'm counting to get each successive point. On the x-axis, our amplitude is 1, because 1 times anything is itself, and we know cosine has the basic shape where it starts at the maximum, back to the midline, down to the minimum, back to the midline, and then back to the maximum, and that's your basic graph. The only thing that changed here was instead of dividing x by 2, we actually did the opposite. We multiplied the x by 2, then the period is 4 pi instead of multiplying 2 pi. So let's go to number 8. Now we got y equals cosine of x pi over 2 plus 1. You can see the amplitude is 1. The period is going to be the same, 2 pi, because 2 pi divided by the same b value here is 1. It's just going to be 2 pi, but what's happening is the graph is shifting right, pi over 2. Remember, the one group of the x has the opposite effect. Pi over 2, you're actually going to write pi over 2, and then plus 1 is going to shift up. So what we're going to do is we're just going to be label our x-axis to pi divided by up into 4 pieces. That's going to be pi over 2 pi, 3 pi over 2, 2 pi, and we can see what we haven't. It's not being stretched at all in the vertical direction, but what's happening, we're shifting right pi over 2 up 1. We can think of that as a new starting point, or like new origin. Okay, it's a cosine graph. Remember, the cosine starts at the maximum. So you're gonna start up here, you're gonna back to the middle line, down to the minimum, back to the midline, and then back to the maximum. So that's your basic graph right there. Now notice the amplitude is 1. So from that starting point, that's why it went up, and then the minimum I went down and 1 from the midline, and again you have the basic shape. It had a normal period of 2 pi. It was just everything was being shifted, right pi over 2 and up 1. So now what we're going to do is we're going to transition over to working with the secant and cosecant graphs. So just a quick refresher, when you think about the cosecant, it's really the reciprocal of the sine graph, see 1 over sine, and when you think of the secant, a function, it is the reciprocal of the cosine function, so 1 over cosine. So we're going to use that information to graph these graphs. So when we look at y equals 2 secant of x, we can think of this as 2 over cosine of x. Now let's start a little bit simpler. Let's just say we want to graph y equals not cosine of x, but 1 over cosine of x, which is equal to secant of x. So let's look at our basic values on the unit circle. So when we think of cosine, we said cosine starts at the maximum, it goes to the middle line, then to the minimum, then back in the midline to the maximum. That's the basic shape, right? This is 1, this is negative 1, this is the pi over 2, pi, 3 pi over 2, and 2 pi, right? But there's this thing when you're at 0, see how the cosine value is 1. So if this is equal to 1 right there, here 1 divided by 1 is still 1, right? When you're over here at 0 pi over 2, see this 0. What's 1 divided by 1 by 0? Well, that's undefined. You can't divide by 0. So what happens is we get a vertical asymptote here. When you're at pi, cosine is equal to negative 1. What's 1 divided by negative 1? That's still negative 1. And then when you're over here at 3 pi over 2, that's 0 again. 1 divided by 0 is undefined. You get another vertical asymptote whenever the graph is crossing the x-axis. That's where your vertical asymptotes are going to be. Now notice when I'm at this point, say for example right here, say for example this is like a cosine value of 1 half. Well, 1 divided by 1 half, when you divide by 1 fraction is like multiply by the reciprocal. So 1 divided by 1 half is really going to be like 2. You're up here, so you can see the graph is looking like this. Now, when you're over here, let's say like when the cosine is negative 1 half, 1 divided by negative 1 is going to be like negative 2, right? So this graph is looking something like this, etc. So what you can see is the cosine graph. If you graph that and you look at these key points where it reaches a maximum or a minimum, that's going to be where the secant graph bends or turns. So that's the same idea when you're looking with the cosecant graph. Remember, cosecant is the reciprocal of sine. So if we wanted to graph this graph, let's just graph y equals 3 sine of pi over 4 times x. The sine graph we know looks like this, okay? The amplitude is 3, so it's gonna reach maximum here at negative 3, and I'm positive 3, and down to negative 3 wherever it crossed the x-axis. That's where our vertical asymptotes are. Okay, sometimes when you're doing this secant and cosecant graph, that helps to draw you know a little bit more cycles. Okay, more periods, and then what you can do now is you can say our graph is going to look like this. Now, the one thing that we haven't done yet is look at the period. So let me do the last year. Usually I do it before I graph this, but I would take pi over 4. Remember, the period is 2 pi divided by pi over 4. Okay, 2 pi divided by b, which is like multiplying the reciprocal, so the pi is cancelled, and it's actually going to have a period of 8. So you can see this going to be right here. It's going to be 8 divided up into 4 pieces, 2, 4, 6, 8. That's our scale, and you've got your cosecant graph. Okay, now switching gears over to tangent and cotangent. When you graph tangent, we're going to be using the values from the negative pi over 2 to positive pi over 2. And remember, from the unit circle, the tangent's the y value divided by the x value. So let's just go ahead and graph the basic parent graph first. And what we're going to do is we're going to start over here at negative pi over 2, and tangent is y divided by x. Now, negative 1 divided by 0, we can divide by 0. That's undefined. So we're going to get a vertical asymptote right here at negative pi over 2. Now, at negative pi over 4 tangents, y over x, anything divided by itself is 1. But we have a negative divided positive, which is negative 1. So over here at negative pi over 4, this is going to be right here at negative 1 at 0, y divided by x is 0 divided by 1 is going to be 0. So that's going to be another key point at pi over 4, which is 45 degrees. Tangent is y over x. Of course, anything divided by itself is going to be 1. And then at pi over 2, tangent y over x 1 over 0, we can divide 0, that's undefined, we get another vertical asymptote. So that's one period. And what's interesting about tangent as opposed to sine and cosine is that the period is 1 pi divided by b, not 2 pi divided by b. So you can see that from negative pi over 2 to positive pi over 2, this actual period of pi. And then what happens is this graph's going to repeat like that. Same thing over on this side as well, and just going to keep repeating like that, but just one period on the cycle from negative pi over 2. Okay, now let's take a look at cotangent. So when you think about cotangent, you're thinking on the unit circle. That's actually the x coordinate divided by the y coordinate. And the unit circle values we're going to use for cotangent are from 0 to pi, okay? 0 to 180. So cotangent of 0 is going to be 1 over 0, which is undefined. So right here at 0, we're going to have an asymptote. Okay, vertical asymptote at pi over 4 x divided by y is going to be 1 because anything divided by sub is 1. And then over here at pi over 2 x divided by y is 0 divided by 1 is going to be 0. Okay, then over at 3 pi over 4 x divided by y is going to be negative 1. And then over here at pi x divided by y, negative 1 divided by 0 is in a bind. So we get another vertical asymptote like that. So you can see the graph is going down to the right, okay? Whereas with tangent is going up to the right. And the other interesting thing again is the tangent half of the graph is to the left of the y-axis, one half to the right, unless it's been shifted. Whereas with cotangent, you can see that the whole graph is to the right of the y-axis. Okay, but again, the graph repeats. So there's going to be another branch over here. Okay, another branch over here like that. It's going to keep repeating, but for one period, one cycle, from 0 to pi to the right of the x going down to the right is your basic graph. And that is all for graphing trigonometric functions. Hope you learned something from me today. And for more information about trigonometry, kindly visit Vermeer's Math TV and Mario's Math Tutoring. That is all. Peace out.